Okay. Hi, my name is Beatrice Fischer, and my soil is located in Chico, California. Chico, California is located in the northern portion of California. And I wanted to add this to have a reference to see, like, in respect to San Francisco, Los Angeles, and San Diego, some notable cities where it falls. So it falls quite northern. Within that, it falls in Butte County in the northwest region of Butte County. Butte County is located in the Great Valley, which is west of the foothills of the Sierra Nevadas and east of the coastal range. And it falls from central to northern California. The geology that's present in the Great Valley is due to the Sierra Nevada range and the Cascade range. So the Sierra Nevada range is located on the eastern portion of California on the border to Nevada. And the Cascade Range runs from Northern California up to Washington and into Canada, with notable peaks like Mount Rainier, Mount Hood, and Lassen Peak. So due to these two ranges, the geology that's found in the Great Valley is granite and metamorphic rock from the Sierra Nevadas, overlain with volcanic mudflow, breccia sandstone, and ash deposits from the volcanic activity from the mountains in the Cascade Range. The formations that are found in the Chico area are the Chico Formation, the Tuscan Formation, and the Red Bluff Formation. These all have differing geologic history and backgrounds. The Chico Formation was formed what used to be a warm, shallow sea. It has fine grained texture and like this yellowish brown color. There's a presence of fossils that's found in this formation, and layers of sandstone, siltstone, and thin layers of limestone are found. It was formed about 90 million years ago during the Cretaceous period in the Mesozoic era. The Tuscan Formation was formed from lahar deposits, and it's found with like volcanic conglomerate deposits and volcanic sandstone and siltstone. It was formed about 5.4 to 2.4 million years ago during the Pliocene period. The Red Bluff Formation apparently is like the oldest Pleistocene alluvial terrace deposit. And it has like this strong reddish orange color. And it's mostly eroded in the Chico area, but it's notable since it is present in the surrounding areas. It was formed about 1 million to 500,000 years ago. The last one I wanted to mention is the Lovejoy basalt. This is not a bedrock or a formation, but it's a unique occurrence of Northern California. It was formed during the Miocene era, and it was produced from a fissure at Thompson Peak, which Thompson Peak is it's like northeast of Chico. This flow went all the way into the Sac Valley, and it formed these like rocks that have this ink black color due to like a high glass content within. The age of them is highly debated, but they're cool rocks, and I thought that it would be a cool like fun fact about my area. So the soils that are present at my location are the Domil Jokerst and Jokerst Domil typic haplozerolfs. They're basically just one has like a dominating of Domil and the other one is dominating of Jokerst. But I wanted to kind of define haplozerolfs because I did not know what that was. But it's derived from hapl, Hapl, meaning mineral horizontation, zer, meaning dry, and alfs derived from alphis soils, which are like moderately leached soils with a high native fertility. So I won't get much super into haplozerolfs. I'm going to focus mostly on Domil and Jokerst, but I thought it was notable. So at my site, It is split about 75% to 25% dominating jokers. So in my backyard, dominating jokers, and in the front yard, dominating domel. This is the aerial taken from the USGS Web Soil Survey. So I want to give that credit. So there are similarities of these two types of soils. They're both formed from volcanic mudflow breccia and found in the volcanic ridges in the Cascade foothills. They both have slopes from like 0 to 30%. They have a mixed mineralogy, so there's not a dominating mineral present in either soil. They have a low shrink swell potential, and they're moderately extensive as they were formed from volcanic mudflow, so it's spread over a relatively large area. Their differences is that the domel series is shallow and somewhat poorly drained, and it's found in mounds and convex areas of the ridge tops and side slopes of the Cascade foothills. It's kind of made up of a gravelly loam, and the bedrock is found 10 to 20 inches below. It's made up of clay and rock fragments, including gravel, cobbles, and boulders, all of varying percentages of the soil. The Joker series is a very shallow soil that's poorly drained. It's found in the swales and planar areas of the ridge tops and side slopes of the Cascade foothills. It's made up of a cobbly loam. Bedrock is found 4 to 10 inches below, and it's also made up of clay, rock fragments, gravel, cobbles, and boulders, again, of varying percentages of the soil. So domel and jokers both were from the loamy residuum weathered from volcanic breccia. It stayed put, and it was left behind. It's remained there. For the hyplo Zorolf portion of the soil, that was formed from like a loamy colluvium derived from volcanic rock, so that formed like a loose heterogeneous mass of soil. It's residual soil, and it was not touched until California Park, which was the neighborhood that my house is located at, until it was developed. So before then, it was mostly just open field, and like nothing really was done on it before. So within that, the land use in Chico is mostly agricultural. As you can see on the map that's on the screen, the light green that falls down here, like on the bottom of the map, is orchard and field crops, and the like darker green is grazing and open land, and then the light yellow is agricultural residential. So it's a very ag-based town. So it makes sense, the soil types and such, but the soil uses was mostly used for livestock grazing, wildlife habitat, watershed, and home site development. So it being like an open field beforehand for wildlife makes sense, and then also for home development also makes sense, as Cal Park was developed on these soils. So as you can see in the picture, we have the wildlife enjoying her habitat, aka my dog enjoying our home. I just thought it was a cute picture, but yeah. So those are the soil uses. So I have two cross sections that I kind of want to share. One of them is from a cross section I found that was located kind of in the southern portion of Chico, but I assumed for like my exact location, it would probably be the same. The PT is the basement complex of the Sierra Nevada blocks. So that's like granite and metamorphic rock that is found. The KC is the Chico formation, and on top of that is the Tuscan formation. So that makes sense because those are two main formations that are found in Chico. Additionally, sedimentary rocks can be found due to river deposits. So at the base of the Sacramento River, those soils are found. For my actual house, it was kind of an estimation. This is more of a soil horizon that I drew up, but the Jokers I split it into like my front yard and my backyard, because Domil was dominant in the front yard, Jokers was dominant in the backyard, and they just had different soil horizons that I wanted to share. So the Joker's soil has an A horizon about 0 to 1 inches thick, a BT horizon of 1 to 4 inches thick, and this R horizon found at 4 inches, and then again, lithic bedrock is found at 4 to 10 inches below the surface. The Domil series has an A horizon of 0 to 1 inches thick, and then it has 3 different BT horizons. So BT1 is 1 to 5 inches, BT2 is 5 to 9, and BT3 is 9 to 14 inches. The R horizon is then found at 14 inches. The lithic bedrock varies from 10 to 20 inches for this soil type. I was able to find some well logs from 2019. It was a study done in 2019. The minimum groundwater that was found in this study was 35 feet below the surface, and the maximum was 135 with a median of 121 feet. So I chose just the shallowest as an assumption. So that's the soil horizon for my house. The geotech properties are pretty similar for both soils, but they differ in some areas. The hydraulic conductivity for the Domil series is 1.2 times 10 to the negative fourth to 3.6 times 10 to the negative fourth inches per second. For the Joker's series, it has a hydraulic conductivity of 1.9 times 10 to the negative fourth to 3.1 times 10 to the negative fourth inches per second. The shear strength, I found, I based my assumption off of a study comparing completely decomposed volcanic soil, like CDV soil, to completely decomposed granitic soil and lateritic soil. They were like comparing those 3 soils to each other, and in this study, CDV was found to have a friction angle of 33 degrees. So I assumed that for these two, since they are both derived from volcanic mud flow and they're decomposed, that a friction angle of 30 to 35 degrees would be a good estimate. The compressibility came from the same study. So the completely decomposed volcanic soil has a larger void ratio to the other 2 soils that were studied in this study. The compressibility of CDV was relatively high compared to CDG and lateritic soil. And the void ratio decreased at like about the same rate throughout the pressure test. I want to mention the hydrologic soil group because it is like an important thing to note for like land development. So I thought it would be I thought it would be helpful to know what hydrologic soil group it is. Both of them are D, which means that they are both poorly drained and have a high runoff potential. So not a lot of infiltration will happen. I was also able to find their cation exchange capacity. So Domil has cation exchange capacity value of 21, and Joker's has one of 21.4. Good potential land uses for these soil types, as stated before with the soil uses, would be residential development, grazing, and open land. I also believe that these soils would be good for rice cultivation, since they do have, they're like poorly drained. Since you have to flood rice fields, it is good to have like a clay-like soil that not a lot of infiltration will happen or like leaching will happen, because you want the rice to stay flooded until it's ready to harvest. Bad potential land use is farmland, so not including rice, rather orchards like almonds and walnuts, and field crops like wheat and corn, just because it's different like harvesting tactics, and they just need different soil types. It'd also probably be bad to develop industrial sites or commercial sites on this type of soil, just because of like the hydrologic soil group being such a low ranking. So changes in the soil structure could be due to like development that's going to happen on these sites. If the site does, like if California Park decides that they want to redevelop their houses, that would be another construction happening on this soil, which would change the structure. So that would include compaction, most likely, which would change just like the characteristics and again, the soil structure. Additionally, due to like the droughts that are happening out in California, there's a high potential of like flooding. If any rain comes, it's a high potential of flooding. So that could lead to erosion of these soils. And then they will be transported and deposited in a new site instead of staying put and staying and still being residual. So with that, are there any questions? Here are my references. Yeah, thank you for listening, and I hope you have a great day. I can't stop recording for some reason. Oh, okay. Thanks.